Hi guys, good evening to all of you. I hope you guys are doing really well. All right, so in the last class also we have started with one of the demo classes from your NCERT of class 6, right? So I welcome you to Scholar IAS, where we consider ourselves to be the one-stop solution for IAS preparation. So today proceeding, we will start off with our NCERT of class 7, and I'll be dealing with one of the topic. And as you can see here, we will be dealing with the topic which is called as your air, right? So similarly, like your class 6, I will be dealing with class 7, and then proceeding, we will also talk about your class 8, 9, 10, 11, and 12, right? So this is not only for your geography, but for all the subjects which are required for your UPSC. Everything will be covered from us from A to Z in terms of NCERT, because NCERT forms the base for you, right? So these live classes are basically to give you a taste of how we conduct our classes, where we will not only be just delivering lectures, but we will also be talking about or basically about the dealing with the questions which are coming from the students, right? So let us begin by first giving you a brief introduction about today's topic. And as you can see here, it is known by the name of air, right? So we will start off with the class with a brief introduction. All right. Then moving on, after we have understood what is the definition of atmosphere or what is an atmosphere, we will be talking about your composition of the atmosphere. Fine. After understanding the composition of the atmosphere, we will talk about your structure of the atmosphere. And when I say structure, I basically means as we move from the surface of the earth to greater heights, how many different layers of atmosphere that we see, right? So introduction, then composition, then structure, and then I will be talking about different concepts which are associated with weather and climate, right? So these are the broad agendas that will be dealt by me today. Fine. So after I am done with the class, I will give you a chance to ask me questions, or in between also, if you have any questions, you can ask me anytime. All right, I'm always available. Fine. So let us begin by first starting with the brief introduction about what is air, or we can also call it as what is the atmosphere. All right, what is atmosphere? Now, all living beings on the earth depends on the atmosphere for their survival. All right, so it says that, see, before we go for the definition, let us look into this. Now, this is the earth, and this earth is being surrounded by a layer of gases, which we can call it as envelope of gases, right? So this atmosphere is nothing but envelope of gases, right, which is surrounding the earth. Mind you, the atmosphere is not only made up of gases like your nitrogen, oxygen, carbon dioxide, which we will talk about, but it is also made up of your solid particles as well as your liquid particles, right? Now, when I mean solid, it can include your dust particles, it can include your salt particles, right? It can include your particulate matters. And when I mean liquid, I can, of course, mean your water droplets, right? So this atmosphere is a combination of gases, solid, as well as the liquid particles, right? So what is the first point stating? It states that all living beings on this earth depends on the atmosphere for their survival. But the question is how? Firstly, it provides us the air we breathe. For example, we need oxygen for survival. So in this atmosphere, what do we have? We have oxygen. Your plants need carbon dioxide for the photosynthesis process. Therefore, your plants are also relying on the atmosphere for survival, right? So firstly, it provides us the air we breathe, and secondly, it also protects us from the harmful effects of the sun's rays. Now, suns emit radiations, right? And one of the radiations which is coming towards the earth is nothing but your UV rays. Now, UV rays are considered to be harmful for us. Now, in the atmosphere, we have one very important gas, which we call it as your ozone, right? Which we write it as O3, right? So these UV rays, if it reaches the surface of the earth, it is considered to be harmful for your plants and animals. So this ozone gas, which is present in the atmosphere, it absorbs the UV rays. It absorbs the UV rays. So this is how your ozone, or one of the constituent matter of the atmosphere, plays a very important role in protecting us from the harmful effects of the sun's rays, right? So your atmosphere, number one, plays a very important role. Number one, how? because it provides us the air we breathe, and secondly, it also protects us from the harmful effects of the sun's rays, right? Then what is the second point? Without this blanket of protection, blanket referring to the atmosphere, we would be baked alive by the heat of the sun during the day and get frozen during the night time. So without the presence of the atmosphere, our temperatures would be very high during the daytime. Why? Because in the atmosphere you have numerous gases, and these gases will absorb the radiations which are coming from the sun, right? So if these gases were not present, then these radiations would directly fall on the surface of the earth, and it would increase the temperature up to a level where your life form cannot exist. Similarly, it also, so basically we can say that the atmosphere helps in maintaining an optimal condition, or it helps in maintaining an optimal temperature so that your life can exist, right? So it makes the environment of the earth neither too hot neither too cold. Understood? So it is this mass of air that has made the temperature on the earth livable. Understood? Fine. So this was about the basic definition or basic understanding of what atmosphere is, right? Then moving on to the next topic, we have to talk about the composition of the atmosphere, right? Now, in the previous slide, what did I say? Your atmosphere can be made up of your different types of gases. It can be made up of your solid particles, and it can also be made up of your liquid particles, right? So what is the first point? Your nitrogen and oxygen are the two gases which makes up the bulk of the atmosphere. So out of all the gases which are present in the atmosphere, which are the two major gases? Number one is your nitrogen and number two is your oxygen. So out of all the gases which are present, 78% of the total composition, it is made up of your nitrogen, and 21% it is made up of your oxygen. So meaning your composition of the atmosphere, if I have to talk about, 99% is made up of your nitrogen and your oxygen, right? Then the rest 1% would include your carbon dioxide. It can include your helium, we have argon, we have your ozone, we have your hydrogen, right? So number one is nitrogen, your number two is oxygen, and what is number three? What is number three? That is my question. Now most of the students make the mistake by calling the third ranked gas to be carbon dioxide, but this is not correct. Your correct answer here is argon, because argon in terms of percentage occupies 0.93%, whereas on the other hand your carbon dioxide occupies 0. How much? 0.03%. So which one is more? Your argon is more. So after nitrogen and oxygen, which is the third largest gaseous composition of the atmosphere, it is your argon and it is not carbon dioxide. And this is very, very important from your exams perspective, right? So keep this in mind. All right. First position nitrogen, second oxygen, third is argon, fourth is carbon dioxide, and then we have rest of the gases like your helium, ozone, hydrogen, etc. Understood? Fine. Then what is the next point? Your plants need nitrogen for their survival, right? And where is nitrogen present? Nitrogen is present in the atmosphere, right? But there is a very interesting fact. So this nitrogen which is present in the atmosphere, they cannot be directly taken from the air. So the plant which is found on the ground, it cannot take up the nitrogen which is present in the air directly. What needs to be done? It needs to be fixed, right? So it needs to be changed in a manner which can be used by the plants. So for example, we have bacteria that live in the soil, as well as some are living on the roots of some plants, right? So these bacteria which are found in the soil as well as living in the roots of the plants, they will take up the nitrogen from the air and change it in a different manner, or change its form so that it can be taken up by the plant. Understood? So this whole process of the nitrogen being taken by the bacteria and changing its form, it is called as your nitrogen fixation. And this is a very important topic from your environment subject perspective, right? So when we move into your environment and ecology, we will talk in more details about your nitrogen fixation. All right. So this whole process is called as what? It is called as your nitrogen fixation, where your atmospheric nitrogen is taken and it is being fixed by the bacteria so that it can be used up by the plants, right? Then let us talk about oxygen. Oxygen is considered to be the second most plentiful gas in the air. Your humans and animals will take up the oxygen from the air as they breathe, and the green plants will produce the oxygen during the process of your photosynthesis, right? Then we have carbon dioxide, which is another important gas, and your green plants will use the carbon dioxide to make their food and release your oxygen, right? So when we breathe in, we take up oxygen and we release carbon dioxide. This carbon dioxide is being taken by the plants. Similarly, the plants will take up the carbon dioxide, and with the help of the process of photosynthesis, it will produce your oxygen, right? So this is how we are both helping each other, right? So your humans or your animals will release the carbon dioxide, which is being used by the plants, right? So this was about the composition of your atmosphere. Then moving on, the next topic of discussion is about the structure of the atmosphere. Now, structure. Now, in the first slide itself, I have mentioned structure refers to the different layers of the atmosphere. So as we move from the surface of the earth to greater heights, how many different types of layers do we see? And each of these layers will have different characteristics, right? All these layers will have its own distinct characteristics. So our atmosphere that I'm talking about, it is divided into 5 different layers, starting from the Earth's surface. So as we move from the surface of the Earth to greater heights, it is divided into 5 layers, and the lowest most layer, it is called as the troposphere, right? So here we have the troposphere, and above the troposphere, the next layer that we see, it is called as the stratosphere. And above the stratosphere, we have the mesosphere, and above the mesosphere, we have the thermosphere, and lastly, the outermost layer that we have is your exosphere, right? So we have troposphere, stratosphere, mesosphere, thermosphere, and then finally, what do we have? We have the exosphere, right? Now, each of these layers will have its distinct characteristics, right? And so let us talk about these layers one by one. So firstly, we will talk about your troposphere, which is the lowermost layer, or it is also the layer which is in contact with the surface of the earth, right? So this layer is the most important layer of the atmosphere, and its average height is how much? It is about your 13 kilometers. So this is about the width of the troposphere, right? So the height is 13 kilometers on average, and the air we breathe exists here, fine. And almost all the weather phenomena like rainfall, fog, hailstorm occur in this layer. This point is very, very important. So if I have to talk about your rainfall, if I have to talk about your snowfall, if I have to talk about your cyclonic activities, if I have to talk about your storms, all these are what? These are nothing but your weather phenomena, different types of weather phenomena. Always remember, all these weather phenomena that I'm talking about, rainfall, snowfall, cyclones, storms, all these are confined in the troposphere only. Understood? All these are found in the troposphere. So as we move above the troposphere, what layer do we have? We have the stratosphere. So these type of weather events cannot be found in the stratosphere, meaning they are confined only to the troposphere, and in no other layers you will find this weather phenomena. Understood? So this is about your troposphere. Then the next layer that we have is your stratosphere. Fine. So above the troposphere lies the stratosphere, and it extends up to a height of 50 kilometers. So above the troposphere, we have the stratosphere, and what is its width? Its width is about your 50 kilometers, right? And this layer is almost free from clouds and associated weather phenomena. Meaning, all these weather phenomena that I was talking about, it is mainly confined to the troposphere, and it is not found in the stratosphere. It contains a layer of ozone gas, and this gas protects us from the harmful effect of the sun's rays. So when I was talking about this in the beginning of the class, I said that the radiations which are coming from the sun, One type of radiation is your UV rays, and if this UV rays falls on the surface of the earth, it is considered to be harmful for the life which exists on the earth, right? So these UV rays are being absorbed by the ozone. And where is this ozone layer found? This ozone layer is found in the stratosphere. Very, very important point. Understood this? So we have understood about troposphere, and then we have also understood about the stratosphere. Now I will ask you a very interesting question. So if I ask you, where do you see, or in which layer are the aeroplanes flying? In which layer your aeroplane fly? Is it your troposphere or is it your stratosphere? In this case, your correct answer will be stratosphere. Why? Because stratosphere, there are no instabilities present. By instabilities, I mean there are no weather activities present, right? So your stratosphere can be considered to be a calm layer. And since it is a calm layer, your aeroplanes find it more feasible flying in the stratosphere rather than in the troposphere, right? This point again is very, very important, right? So we have understood troposphere as well as your stratosphere. Then the next layer that we have is your mesosphere. So this is the third layer of the atmosphere, and it lies above the stratosphere, and it extends up to a height of 80 kilometer. Fine. So what is the width of the mesosphere? It is about your 80 kilometers, and the meteorites will burn up in this layer on entering from the space. So the meteorites which is entering, it will burn up in which layer? It burns up in the mesosphere, which is very, very important, right? Then as we move from this mesosphere, the next layer that we have is your thermosphere. In the thermosphere, your temperature rises very rapidly with increasing height. So in the thermosphere, where what is happening, as we move up or as the height increases, your temperature also starts to increase. But the question is why? Because in the thermosphere, this layer is getting heated from the sun's radiation. Since this layer is closer to the sun, it gets up heated directly by the sun's radiation, and because of this, as the height keeps on increasing, your temperature also keeps on increasing. In case of your troposphere, as the height increases, your temperature starts to decrease. In case of your stratosphere, with increase in height, your temperature starts to increase. Why? Because here we have the presence of the ozone layer, and this ozone layer will absorb the UV radiations, and because of this, the temperature of the stratosphere increases. Then in mesosphere, the pattern again changes, where with increase in height, your temperature will decrease, right? So troposphere, increase in height, temperature decreases. Stratosphere, with increase in height, temperature increases. In mesosphere, it decreases. In thermosphere, it increases, right? And in this thermosphere, we have a very important layer which is called as the ionosphere. And this is a layer which is made up of your electrically charged particles. It is made up of your electrically charged particles, right? And it is the presence of these electrically charged particles that makes radio communication possible. That makes radio communication possible. Very, very important point. So your radio communication plays a very important role. It allows for radio communication to happen, and it is possible because of the ionosphere which is present in the thermosphere. Again, very important point from your exam's perspective, right? And it extends between the height of 80 to 400 kilometers, and this layer helps in your radio transmission. Fine. Then we have the exosphere, which is the outermost layer, and it is the transitional layer. Okay, your exosphere is considered to be a transitional layer between the atmosphere of the earth on one side and your outer space on the other side. Fine. So the uppermost layer of the atmosphere is known as the exosphere, and this is a very thin layer, right? Because here the density starts to decrease, your gravity plays a very small role, or your gravity starts to decrease, right? And therefore this is considered to be a very thin layer. And this layer is made up of your light gases, like we have your helium, and then we also have your hydrogen. Understood this? So these are the different layers of the atmosphere, which we call it as the structure of the atmosphere. Fine. Next, what do we have? Next, we have is the weather and climate, which is a very different topic from what we have learned as of now, right? Okay. So, what is weather and climate? Let us look into this. Fine. So, your weather is the hour-to-hour or day-to-day condition of the atmosphere, right? And your weather can change dramatically from day to day. However, the average weather conditions of a particular place for a longer period of time represents the climate of a place. Fine. So weather is talking about the climatic features like your rainfall, your temperature for a very short span of time. Then what is climate? Climate, on the other hand, is the average of all the weather activities for a longer span of time, right? So weather is a short duration measurement, whereas the climate is considered to be a long duration measurement, right? So that is the difference between weather and climate. Now, in weather and climate, there are a lot of dynamics associated with it, or there are a lot of concepts which are associated with it. And the first thing that we will talk about is the temperature. Fine. So what is temperature? The degree of hotness and coldness of the air is known as the temperature. Fine. Very simple. The degree of hotness and coolness of the air is called as your temperature. And the temperature of the atmosphere changes not only between day and night, but also it varies from season to season, right? So this is about your temperature, right? Then what do we have? Then we have your very important concept, which is called as your insolation, right? An important factor that influences the distribution of the temperature is called as insolation. So now here we have to understand what is insolation. Fine. Insolation is the incoming solar energy which is intercepted by the earth. Now here we have the sun, right? And here we have the earth, right? So what I was saying, I was talking about your sun's radiation, right? So these sun's radiations are being directed towards the earth and it is reaching the surface of the earth, right? So these radiations which are being emitted by the sun and which is reaching the earth, it is called as the insolation. Fine. So another important factor that influences the distribution of temperature is insolation. So what is insolation? Insolation is the radiations which is coming towards the earth, right? Which we call it as the sunlight, right? And the amount of insolation decreases from the equator towards the pole. What does this mean? It means that, see, this is the earth, right? So here we have the sun. Now the sun radiations falls almost vertically at the equator. It falls almost vertically at the equator, and as we move away from the equator, your sun rays will start to get oblique, or it starts to get slanted, right? So at the equator, what happens? As the sun rays are almost vertical, therefore your temperature will also be more. But as we move away from the equator towards the pole side, as we move away from equator towards the pole side, what will happen? Your angle keeps on increasing, therefore your heat concentration of heat will also start to decrease. Your concentration of heat will start to decrease, and because of this your temperature will also start to fall, right? So insolation is nothing but the incoming solar energy which is intercepted by the earth, and the amount of insolation decreases from the equator towards the pole. And that is the reason why as we move from the equator towards the poles, your temperature starts to decrease. Your temperature will start to decrease, right? So this is about your insolation. Then the next concept that we have is your air pressure. Fine. Now what is air pressure? Air pressure is defined as the pressure which is being exerted by the weight of air on the earth's surface. Now this is the earth, right? Here we have the atmosphere, right? So atmosphere is made up of what? Different constituents. All these constituents will have mass, and in this mass what will act? Your gravity will act. This is nothing but your weight, right? So all this mass or weight of the atmosphere is being felt where? It is being felt on the surface of the earth, right? So as the whole weight of the atmosphere is being felt on the surface of the earth, what will happen? We call this as pressure, meaning the atmosphere is exerting a pressure or force on the surface of the earth, which we call it as atmospheric pressure. Fine. So the whole weight of the atmosphere as it is felt on the surface of the earth, we call it as the atmospheric pressure, right? So where do you think will your atmospheric pressure be maximum? Where do you think your atmospheric pressure will be maximum? Now the whole weight of the atmosphere is being felt on the surface of the earth. So of course your correct answer, by common sense you can say that the atmospheric pressure is maximum at this surface. And as we move from the surface of the earth to greater heights, your pressure keeps on decreasing. Your pressure will keep on decreasing, right? So as we go up the layers of the atmosphere, the pressure falls rapidly, and the pressure is greatest at the sea level, meaning at the surface of the earth, and decreases with height, right? Very important. Next point. In areas where your temperature is high, the air gets heated and rises. All right. So if this is the surface of the earth, what happens? If the temperature in this area is very, very high, all right, if the temperature in this area is very high, what will happen? The air which is present here will also get heated up. And if the air is here getting heated up, what will happen? As it gets heated up, its density will start to decrease. And as its density decreases, the air will get lighter and it will start to rise up. And as it rises up, at the surface of the earth, a vacuum is created, right? Because there will be less amount of air will be present in that particular area because your air has risen up. Therefore, in these areas which are hot, all right, which are hot, where the air rises up, these areas will have low pressure. Very, very important. So in areas where your temperature is high, the air will get heated up, and as it get heated up, its density will start to decrease and it will rise up, and this will create a low pressure area. Fine. And your low pressure area is associated with cloudy skies and your wet weather. So always remember, in low pressure areas, these areas are marked by your rainfall, your cloud activities, etc. Fine. So always remember, when your temperature increases, your pressure will start to decrease, right? So the air will always move from high pressure areas to the low pressure areas. So at the surface of the earth, if we have two areas, suppose here we have a high pressure and here we have a low pressure. Always remember, if this is the condition, at the surface, the air will always move from high pressure towards the low pressure areas, right? Now suppose here we have the low pressure, in the adjacent area we have a high pressure. Your air will always move from high pressure to low pressure along the surface of the earth, right? Now this movement that I am talking about, this movement of air from high pressure to low pressure which I am talking about, right, these type of movement of air are called as your winds, right? So what are winds? The movement of air from high pressure, all right, to low pressure area, it is called as your wind, right? And your winds can broadly be categorized into three different types. We have your permanent winds, we have your seasonal winds, as well as we have your local winds, right? So what are these permanent winds? Now if you look into this diagram which is shown here, you will see that the whole earth is being covered with different types of winds, right? So there are some winds which are blowing in this direction, there are some winds which are blowing in this direction, some of the winds are blowing in this direction, right? So these are nothing but the different types of permanent winds. By permanent winds you mean these are those winds which covers the whole surface of the earth throughout the year. And there are three different types of permanent winds. We have your trade winds, we have your westerlies, and then we have your easterlies. So what are these trade winds, westerlies, and easterlies? When we move into the NCERT of class 7, you will understand the various dimensions which are associated with it, right? But for the time being, you understand trade winds are those winds which are blowing from the subtropical region towards the equator side. Then we have the westerlies which are blowing from the subtropical high pressure areas towards the subpolar areas, which is having low pressure. And then we have the easterlies, which starts from the polar region, and moves towards the subpolar areas, right? So now for the time being, you understand that there are three important types of permanent winds. We have your trade winds, we have your westerlies, and then we have the easterlies, right? And these winds will blow constantly throughout the year in a particular direction. So this type of winds will never change its direction. It will always remain constant, right? Then what do we have? Then we have your seasonal winds. Seasonal winds, as the term is itself suggesting, these are those winds which changes its direction, which will change its direction according to season. For example, these type of winds are seen in India, and your example would include your monsoon, right? Because if you look at the phenomena or the characteristics of the monsoonal winds, you will notice if this is India, during the rainy season, your monsoons are flowing in this direction, right? And then you will notice that during the winter season, your wind is blowing in the reverse direction. So according to season, your monsoon is also changing its direction, right? So this is called as what? These are called as your seasonal winds. These winds will change their direction in different seasons. Example, your monsoon, right? Then we have your local winds, as the term is itself suggesting. These are found in a particular location locally, right? So this blows during a particular period. For example, it can blow in the daytime, or it can blow in a year also in a particular small area. So these are those winds which are found in a particular location only. And your examples would include your land breezes and your sea breezes, right? Which is seen during the daytime as well as in the night time. Fine. Then the last concept that we will talk about is your moisture. What is moisture? Fine. All right. So when the water evaporates from the land and different water bodies, it will become water vapor, right? Suppose your sunlight is falling on the your ocean, what will happen? The temperature will increase and your water will get converted into water vapor, right? So this water vapor will now be present where? This water vapor will now be present in the air, right? And the moisture in the air at any time is known as your humidity. So this water vapor which is present in the air, it is called as what? It is called as your humidity. Fine, very important. And as the air will get warmer, its capacity to hold the water vapor will also increase, and so it becomes more and more humid. So we can have two different types of air, a hot air and a cold air, right? Always remember, in case of hot air, its capacity to hold moisture is more. Its capacity to hold moisture, it is more. And in case of cold air, the capacity to hold moisture, it is less. Very, very important. Humidity, we have understood, it is the amount of water vapor which is present in the air, right? And your cold air and hot air, the moisture holding capacity is more for your hot air and it is lesser for your cold air. Fine. And the water vapor will rise and then it will get to start cool. So if this is the surface, what will happen? Your moisture will now start to rise up. That is, your water vapor will rise up, right? As it rises up, it will expand in both the direction. And as it expands, what will happen? Your heat per unit volume will start to decrease because your volume in the denominator is increasing because it is expanding, right? So as your heat per unit volume starts to decrease, what will happen to the air? The air will now start to get cooled down. So what will happen to the water vapor? As your water vapor starts to cool down, your condensation process will begin. And because of this, what will happen? Your water droplet will now get converted into, your water vapor will now get converted into water droplets, right? So when the water vapor rises, it starts to get cooled, right? And the water vapor condenses, causing formation of droplets of water. Your clouds, when we talk about, these are nothing but masses of such water droplets. So these water droplets, your water vapor getting converted into water vapor, and as it gets combined, or when it comes close together, it results in formation of your clouds, right? And when these droplets of water become too heavy to float in the air, what will happen? It will come down as precipitation. So when these water droplets come together to form clouds, at one point of time, what happens? This becomes very heavy. It becomes so heavy that the atmosphere is not able to hold it. And because of this, what will happen? These water droplets will fall from the sky towards the surface of the earth, and this is called as your precipitation. And your precipitation can occur both in the form of rainfall, and it can also occur in the form of snowfall. Fine. So your precipitation that comes down to the earth in your liquid form is called as the rain, and most of the groundwater comes from the rainwater. Fine. So this is about your chapter number 4 of class 7 NCERT of geography, right? So let us do a quick revision before we stop. So firstly, we have understood what is an atmosphere, which is your envelope of gases, and it also contains your solid as well as your liquid particles, right? Then moving on, we have talked about the composition of the atmosphere, how it is made up of your different gases like your nitrogen and oxygen, which together is about your 99%, right? Then we have also talked about other gases like carbon dioxide, then how what is the process of nitrogen fixation. Then we have talked about the structure of the atmosphere, how it is classified into 5 different layers. We have your troposphere, we have stratosphere, mesosphere, thermosphere, and then we have the exosphere, which is the outermost layer, right? Then we have talked about the difference between your weather and climate and what are the different concepts which are associated with it. For example, we have understood what is temperature. Then we have understood what is insolation, that is the radiation which is coming from the sun, right? Then we have also talked about air pressure, how the weight of the air is being felt on the surface of the earth. And as we move from the surface of the earth to greater heights, your pressure starts to decrease, right? Then we have understood winds. What are winds? Winds are nothing but the air which is blowing horizontally along the surface of the earth from high pressure to low pressure areas. And there are 3 different types of winds. We have permanent winds, we have seasonal winds, and then we have local winds. And your permanent winds are of 3 types. We have trade winds, we have westerlies, and then we have the easterlies, right? And then we have understood the concept of humidity, which is nothing but the amount of water vapor which is present in the air. And as this water vapor rises, it starts to get cooled down, and because of this, the condensation process starts, and your water vapor gets converted into water droplets. And when these water droplets come together and it becomes heavy, it starts to fall down on the ground as your precipitation. Fine. Okay, let us deal with 2 very simple questions which are found in your NCERT. Firstly, which of the following gas will protect us from the harmful sun rays? As we have already seen, it is your ozone, right? Where your ozone layer is found where? Your ozone layer is found in the stratosphere, right? So your correct answer is ozone, right? Then lastly, what do we have? We have when the precipitation comes down in the form of liquid, we call it as what? As we have already seen, we have it is called as your rain. And if it was in the form of solid, we could have called it as your snow, right? So this is where your the topic or the chapter number 4 of NCERT ends, right? Now, if you guys have any questions, you can kindly ask me. I'm here to entertain any type of questions that you will ask. Fine. I'll give you some time. If you have any doubts, you can please ask me. Any doubts? Okay, fine. So this is what is from my side. If you guys have any doubts, you can surely ask. We will be coming with live classes like this on a daily basis or very frequently, where we will be entertaining doubts from the students, not just with respect to your subject of geography, but also all other subjects, which is important from your UPSC prelims perspective, right? So not only we will be giving you live classes, but any doubts that your students will have, we will also entertain them, right? Then in our the scholar your NCERT the program that we are beginning or we have already started, we are not only giving you your recorded lectures, we will give you live lectures. Then we will also give you doubt clearing sessions, and along with that, we will also give you mind maps. Mind maps are very helpful for your revision purposes, right? When you are going for an examination, for an example 10 days before your prelims, these mind maps will come really handy in nature because it helps you to memorize much more faster, right? So this is a wholesome package that we are offering And if you have liked our classes, kindly do join our course, which will be very helpful for you, right? So this is what is today from my side. You guys have a very good evening. All right. Thank you.